Years ago, I had an idea that might now be more interesting than ever. Generating electricity with an exercise bike to charge batteries and power an inverter to run a workbench or small workshop totally off the grid. As luck would have it, I found an old exercise bike from the 70s that uses a DC motor as a generator brake and can thus generate electricity directly. In this video I will show you my attempt at building a workbench with integrated electronics that will allow you to work on projects while exercising, generating the electricity needed with your legs alone. This exercise bike was built in 1978 in Germany. Back then it was advertised as the first computer-controlled exercise bike in the world. It was used in hospitals and other medical facilities. It cost today's equivalent of many thousands of euros or dollars. Today it can be found here and there for just a few bucks. I begin by taking its enclosure apart temporarily to clean it from the inside and show you how it works internally. This somewhat rusty part is a flywheel rotating outside of the housing of a brushed DC motor, and only professional grade bikes like this will have a DC generator inside. The vast majority of bikes out there uses either mechanical brakes or eddy current brakes. This is a massive heatsink that was actively cooled down by a fan attached to the motor shaft. Behind a coated circuit board we find bipolar power transistors. They were used to put an electric and thus a mechanical load on the generator. They were literally turning the electric energy generated into heat, a total waste. We clean everything, remove the rust and the old electronics that we will no longer need. All we need is the two thick wires that connect directly to the motor brushes. And by connecting a battery to the motor, I can show you that this is indeed an electric motor. Sitting on the bike, I want to build a workbench surface that will surround me, allow me to work while exercising. In true post-apocalyptic fashion, used wood that I found on the trash is used to patch together a workbench surface. Plywood on top, cheaper OSB on the bottom, a large surface is created. And I take a bunch of stock from a scrapyard to stick weld a support structure for the workbench surface. Even though I have been using TIG and MIG for years, at the moment I voluntarily revert to the more old-fashioned techniques, stick welding and oxyfuel. The workbench surface will be refined, but first I want to know if I picked the right height and surface area to do practical work on it. With this temporary setup, I start to work on the electronic setup. I first need a proof of concept before any refinements will take place later in this video. And here is the setup. On the left hand side, a 12-volt lead acid battery. Then 3 digital multimeters are part of the setup. The big part in the middle is an off-the-shelf solar charger, as used in photovoltaics island systems. And then an ordinary 12-volt light bulb is attached as a load. I want to mention here that this particular solar charger can be used on different voltage levels, with a 12-volt, 24-volt, 36-volt or 48-volt setup, and it will recognize that automatically. Here I'm first using 12 volts. I start to ride the bike at a moderate pace and start to take measurements. The fluke meter on the left measures the generator voltage, at least once it's higher than the battery voltage. The second meter displays the generator current. The display of the solar charger shows the battery voltage, and the third DMM the output current flowing through our load, the light bulb. In order to calculate the input and output power, just multiply voltage and current. The currently generated input power is roughly 70 watts at a very moderate pace. In order to power tools and devices built to be operated using the power grid, we need an inverter turning the 12-volt DC into 230 volts AC. At least here in Germany, that is. For that we have added this 1000 watt inverter to the setup. And I connect a power drill to the inverter and operate the exercise bike, trying to at least match the power needed by the drill. At the moment the drill draws around 130 watts, while I generate around 140 watts of electrical energy with my body. The pace is still moderate, but the physical resistance is much higher than with a small light bulb as a load. The inverter works well so far, but please note that the inverter is only a square wave inverter. The oscilloscope screen is supposed to show that. Unfortunately, my scope is running on its last leg and it is very hard to film CRTs, but you can guess what the shape is actually looking like. Square wave is kinda okay for universal motors without phase-fired speed control and for many switch mode power supplies, but might cause problems in devices with mains transformers, phase-fired controllers, induction motors, and in audio equipment. If you can, get a sine wave inverter. While I was working on the electronics, my girlfriend has helped in giving the workbench a more unified appearance, a more finished surface and a protective coating of paint. I, on the other hand, have built meters and connectors into the workbench. The off-grid workbench is now finished. Let's have a look at it and test it. I added this panel here that has a number of meters built in that show all the readouts of the DMMs we used in the experimental setup. This voltmeter reads the generator voltage. The mounting posts down here allow to tap into that generator voltage directly. This ammeter displays the input current flowing from the generator into the solar charger. And right now, the charger display shows the voltage between the poles of the lead-acid battery. That output voltage is also displayed on this meter here. This meter down here is supposed to be a second ammeter, but at the moment there is a voltmeter here. I will have to convert it into an ammeter, and I've shown how that is done in an earlier episode. A link to that video is in the video description. I also added this power meter here that displays the output voltage, current, and power output of the inverter. Unfortunately, its internal power supply doesn't work well with the non-sinusoidal AC. That's why I will disable it for the tests. And let's test the workbench then. And I start with an example that I think is both well suited and that also has a rather low energy consumption: soldering. Both the lamp and the soldering iron are powered by the workbench. At a combined power rating of only around 35 watts, only a very moderate pace is required in order to keep the battery charged. In fact, it is quite easy to deliver more than the 35 watts and charge the battery to a higher voltage while working. As you can see, my upper body is in motion, and of course this makes it harder to keep a steady hand, but I don't find it too difficult. Also keep in mind with all these practical examples here, you don't have to exercise while working. That's what the battery is good for. You could, for example, read a book while you exercise, then sit still while you actually work. Here's the next example. This is a cordless power drill. Well, it used to be cordless before I lost the battery. I simply soldered 2 wires to the battery contacts. No inverter is needed here. The power drill can be connected to the lead-acid battery directly via these mounting posts here. And both drilling holes and screwing in screws works just fine. But what if you need more power? Well, we only need to connect this power drill to the outlet and we can start drilling holes with much more force. This power drill needs between around 100 and 400 watts depending on the mechanical load. Delivering 200 watts of electrical input power with the exercise bike is possible, while around 100 watts are reasonable. In other words, if you use the power drill at maximum power, you will have to charge the battery for a longer duration than the time span in which you actually use the drill. But what about other power tools? Well, a few months ago I made a video about this device here, the METABO Multitool, a German invention from the 1960s that consists of a power drill powered platform that can be converted into a table saw, drill press, and many other things. In this case, I'm setting it up as a lathe, and I try to operate the wood lathe while using the exercise bike. I'm not saying it's perfect, but it clearly does work. At least I think that the off-grid Workbench and the METABO Multitool are a match made in heaven. And of course, many other uses could be possible. Why not exercise while playing your favorite video game and generate some electricity while you're at it? What do you think should I attach to the Workbench next? Any suggestions? Please comment in the comment section below. And if you like this video and would like to see more off-grid ideas and inventions, please give this video a like to let me know to go full steam ahead with more videos of this type. Meanwhile, another repair-a-thon is in the making. In the upcoming episode, we will build more awesome machines from stuff I found at the scrapyards. And if you want to support this channel actively, please consider visiting my Patreon under patreon.com/tpai. There also is a donation link in the video description, by the way. See you soon, guys.